Chapter 6, Chemical Calculations. Well, this is a chapter full of calculations. We will introduce a concept that is called moles, and we will do a lot of calculations involving moles under different circumstances. If you're good at math, this chapter should be relatively easy for you. If not, don't be discouraged. Make sure you follow the lecture through. Make sure you understand the stuff we discussed. I still believe you can master this. First, a new concept, formula mass. The formula mass of something is the sum of the atomic masses of all the atoms in its formula. For example, the formula mass of calcium chloride. How do you get that? You use the atomic mass of calcium, which is 40.08, plus 2 times the atomic mass of chlorine. There are 2 chlorine atoms. Chlorine is 35.45 times by 2. After the calculation, you're going to get 110.98 AMU. AMU is the unit for formula mass because it is a unit for atomic masses. Another example, the formula mass of magnesium nitrate. All right, there are a couple ways to set it up. The first one, you start with the atomic mass of magnesium. Now, here in the formula, you have 2 nitrate units. Each nitrate is 1 nitrogen and 3 oxygens. So 1 nitrogen, 14.001, 3 oxygens, 3 times 16.00, 16.00 is the atomic mass for oxygen. You add the 2 together. Once you get a number, you times it by 2, which tells you there are 2 nitrate units. Here is another way to set it up. All right. Again, you start with magnesium 2431. Now let's look at the nitrate unit again. You have 2 NO3. Each NO3 has 1 nitrogen, 3 oxygen. 2 NO3 will give you 2 nitrogen and 6 oxygen. And that is how it is set up. Magnesium plus 2 times nitrogen plus 6 times oxygen. Either way, you're going to get the same answer. Now, we're ready to move on to the mole concept. However, before that, I would like to have a quick review on the topic of atomic masses. Do you remember how do each element get their atomic masses? How do we get 16.00 for oxygen? How do we get 24.31 for magnesium? Do you remember how they are calculated? Well, they are calculated by using carbon-12 as an example, as a reference. Carbon-12 is assigned with 12 Mu. Whatever mass of one carbon atom it is, we don't care. We just call that mass 12 Mu. All other elements use their own mass to compare with the mass of carbon-12 to get their own AMU numbers. That's how they were calculated. Now we know how the atomic mass of each element is calculated. I put some numbers here, okay, as example. So if the mass of one carbon-12 atom is 12 Mu, the mass of one carbon atom will be that, one hydrogen will be that, one oxygen will be that. Okay? Remember, carbon includes carbon-12, 13, 14. Carbon-12 is just an isotope of carbon. All right, again, if the mass of one carbon-12 atom is 12 AMU, the mass of one H2O formula mass will be 18.015. You use the atomic mass of hydrogen times by 2 plus the atomic mass of oxygen. That's how you get it. And the mass of one CO2 carbon dioxide formula will be 44.01. Again, these are their relative masses in AMUs. Mole is a very important chemistry concept. But before I show you the definition, I would like to describe to you what kind of unit it is and why do we need such a unit. Mole is a concept that links the mass of something with the number of particles of that thing. It links the mass and the number of particles. Why do we need it? So let's assume you are performing a chemical reaction in the lab. The procedure asks you to mix certain grams of substance A with certain grams of substance B. For example, they ask you to mix 12 grams of A with 16 grams of B and let the two react. But you know that when A and B react, they do not react by grams, they react by particles. Each A molecule may react with 1, 2, 3, or some other number of B molecules depending on the reaction. Which means when you mix 12 grams of A and 16 grams of B together, you need to know how many A particles have been added to the system and how many B particles have been added into the system so that you know if the two are in the correct ratio requested by the reaction. So now you see we do need a concept that links the mass and the number of particles together. Here we go. The definition of a mole. What is it? A mole is the amount of a substance that contains as many elementary particles. Elementary particles could be atoms, molecules, ions, formula units. So the amount of a substance that contains as many elementary particles as there are atoms in 12 grams of carbon-12. So this definition is telling you the number of atoms in 12 grams of carbon-12 is defined as 1 mole. How many atoms are there? Well, we don't know it yet. We don't care at this moment. Regardless how many atoms are there, I define that amount as 1 mole. Why do they do this? What is the benefit of this? Well, here we go. Let's come to the atomic mass definition. The atomic mass of carbon 12.01, hydrogen 1.008, oxygen 15.999. They are all defined. These are the mass of one atom when the mass of carbon-12 atom, the mass of one carbon-12 atom is defined as 12 AMU. That means all of this 15.999 AMU of oxygen, 1.008 AMU of hydrogen, 12.01 AMU of carbon, 12 AMU of carbon-12, they all have the same number of atoms, 1 atom. All right. These are the relative masses of different atoms. So they all represent the mass of one certain atom. If that's the case, then if we expand this carbon-12, if we define 12 grams of carbon-12 is 1 mole, then we know 12.01 grams of carbon will have the same number of carbon atoms as 12 grams of carbon-12. They will have the same number of atoms. Does it make sense to you? You will also know that 1 mole of hydrogen will be 1.008 grams. 1 mole of oxygen will be 15.999 grams. All of this will have the same number of atoms. How many? We don't know yet. We just call that number 1 mole. Well, we just did the formula mass. After defining 1 mole like this, we will know 18.015 grams of water will have 1 mole of water molecules. 44.01 grams of carbon dioxide will have 1 mole of carbon dioxide molecules. They all have the same number of elementary particles, although we don't know that number yet, but we call that number 1 mole. That's the benefit by using carbon-12, 12 grams of carbon-12 to define 1 mole. By doing that, we can use these AMU numbers right away. What we see here, before we proceed, what we see here is that the mass of 1 mole of a molecule, in this case water, is the same as the AMU number. Numerically, the mass of 1 mole of something is the same as the formula mass, but they have different unit. Mass of 1 mole is in the level of grams. Formula mass is in AMU. All right, again, numerically, they're the same. However, they have different units. Now, one more question. What is that number in 1 mole? Okay, that number of elementary particles, what is it? Luckily, we don't have to worry about that. A great scientist called Avogadro figured it out for us. All right? There are actually 6.02 times 10 to the power of 23 units in 1 mole of anything. Okay. 1 mole of some molecule will be 6.02 times 10 to the power of 23 molecules. 1 mole of atoms will be 6.02 times 10 to the power of 23 atoms. That means, let's use carbon as example. (12.01 grams of carbon, which is 1 mole, which will have that many 6.02 times 10 to the power 23 carbon atoms. Here we linked mole, number of particles, and grams together. A quick review. A mole, the Avogadro's number, the mass of 1 mole of a substance. The mass of 1 mole of a substance is the same as its formula mass numerically. If you are asked to calculate the mass of 1 mole of something, you just calculate its formula mass. You know how to calculate formula mass, don't you? We just talked about this at the beginning of this episode. You add the atomic masses of all the atoms inside the formula. All right, you just do that, but make sure your unit needs to be grams for the mass of 1 mole of a substance. The the unit for formula mass of is AMU. However, again, numerically, they're the same. So when they ask you to calculate the mass of 1 mole something, you just calculate the formula mass, but make sure you label the unit with grams. For example, what is the mass of 1 mole of silver nitrate? Well, atomic masses are given nitrate, silver, nitrogen, oxygen. All right, you're going to add the atomic mass of 1 silver, 1 nitrogen, and 3 oxygens. That's it. Silver, nitrogen, 3 oxygen. Make sure the unit is in grams. All right, what else? There are 6.01 times 10 to the power of 23 units of particles in 1 mole of that particles. All right, we understand that. Avogadro's number is 1 mole. 1 mole is Avogadro's number. All right, that's it for today. See you next time.